Hello guys, welcome back to my channel. We are continuing with this layout. We have already done goods receiving, dry storage, cold storage, pastry preparation. We are in the pot wash area. The pot wash, we did the triple bowl sink. The rack is the same as the one in dry storage. We are not going to do a rack. So under the pot wash, we are going to do a grease trap which will be connected to the drainage of the sink to the main drainage of the kitchen, right? And the same grease trap will feature in the dishwash area and the meat prep area. Alternatively, you can have one grease trap outside or at a strategic point in the main drainage of the kitchen, but it is strongly suggested that you have grease traps under the sinks. All right, now how does the grease trap look like? Here is the grease trap, the drawing of the grease trap. The size is 500 by 400. The height is 300. Let me pull a nice drawing of the grease trap. Yeah, so this is the grease trap we are talking about. We have a lid and the handle is at the front where, you know, the lid is supposed to be sliding this way. It has an edge flange on this side, and at the front, the back, it is opened. Now it is a two-stage grease trap, right? Very good. Where is that zoom button? Can't seem to find the zoom, the plus button, right? The inlet, the first stage, we have the strainer basket. All right, let me open the grease trap. Open grease trap, projects, tutorial, grease trap. Yes, here is the grease trap. We have the inlet, strainer basket from the first stage. It's a two-stage grease trap. We have a partition here which is not touching the bottom of the grease trap, so the water plus the waste goes in through here. It gets sieved by the strainer basket, which is removable, of course. There is a gap here, then it goes, there is another partition here which touches separating the first chamber and the second chamber, and it touches the bottom of the body of the grease trap, and the water flows to the second strainer basket, which also is removable. And there is another plate here which kind of protects the water from flowing directly to the outlet. The water should flow down here through this opening to the outlet, right? So there it is. There is your grease trap. Look at the profile of the first partition. It looks like that. Then this partition has that profile, and the profile of the plate that protects the outlet looks like that. If I could go to the through this other PDF, we have the profile of the plate protecting the outlet. Looks like this. It has an edge flange here of 45 millimeter and a degree of 130. This is 20, this is 280. Right, the first partition, this is the profile. It has a height, total height of 280. I didn't do my dimensioning well, they are not very clear. This vertical one is 210. There is a bend here of 20 millimeter. There is this one here is about what, 80 millimeter, and on the top is 25. Let us just get right into designing. You're going to see it as we continue. Now we go to new drawing, new part, and choose the top panel, sketch, center rectangle, dimension, the body is at 400 by 4 by 500. Right, we have different we have various sizes, so you can do a size that fits your need. Now, sheet metal base flange, the thickness of the material is 1.5, and the grease strap should be made of stainless steel grade 3 or 4. Now we do an edge flange round the grease strap. And the height is 300 millimeter. Now we also add an edge flange here, round, and this is end condition blind. This is 20 millimeter. Right click. Now we do closed corner, butt type. 0.1 millimeter is the opening. We choose this face, and we don't want it matching face, matching with no, I did choose. Let me clear this. So the first face is this, and the face it matches is this. Then this face matches with this face. Notice I'm choosing one face and matching it to another. This face, choose the face it matches. You click on that, then you choose the other face. You can do two and then mirror. Alternatively, you can choose all the faces that you want without going to mirror them. Whatever works for you. Yeah, with all the faces chosen, click OK, and your closed corner is done. Then we go back to edge flange again, choose that edge, this edge, this edge, and this edge. End condition blind, 15 millimeter. Now during your fabrication, this thing known as safety is very key. So to avoid having a sharp edge, you do a double fold all around that edge flange, and that one too. I chose the wrong one. That and that. Yes, that's about right. Okay, let us create the opening for the the inlet, and the diameter, circle diameter of the inlet is smart dimension 51.5. You don't want a big opening because the tube is there 51. You don't want a big opening for you to start using a lot of welding to fill the gap, so it should be somewhat tight fit. Now the inlet should be slightly above the outlet, and from the top is 50 millimeter to the center of the inlet. We want to add a relationship to the origin. The center and the origin should be vertical. Center of the inlet should be vertical to the origin. Then go to future, extrude and cut, link to thickness. Yeah, there you have your opening. Let us create the outlet. Outlet is also is 50 millimeter. What's going on? How many circles do we have? One circle. Smart dimension 51.5. From the center of the circle to the top should be about 105 millimeter. 105 is okay, even 100, just to make sure it is slightly lower than the inlet. So the center of the circle again and the origin should be vertical. Feature, extrude and cut, link to thickness. That's okay. Yes. Our grease trap is taking shape. Go ahead and save. We will save it on projects. I hope you are saving your work accordingly. Yeah, you don't have to follow mine. This is part number 1. Call it PW1A body. Now let us evaluate and see. Before we evaluate, we see the flat pattern. There you go. Let's see whether this, okay, ideally when you are doing your cutting, it is not economical to cut this grease trap from one sheet, right? Because you will have a huge waste. You can cut this part, then this and this side parts you cut from an offcut, so that you may avoid wasting your material. Because when you look at this being your stainless steel sheet and you cut the whole part from one sheet, you will have an offcut here, another offcut here, another offcut, and another offcut, which ideally it might be a huge waste. But if you cut it like this will be an offcut that you can use to do other things. Well, if you don't have financial constraints, it is recommended that you cut it this way, because you will avoid having a welding here and another one here. You will only have weldings on the edges. You will only weld here, here, and here. No welding here, no welding here. That is if you have no financial constraints, right? But if you are trying to save on material, cut this part, the bottom part, and this as one unit, then do the bending. Then you cut this part, do bending, and this other part, do bending, and weld here and here and here, then here, here, and here, right? Yeah, hope we are on the same page. I want want to evaluate measure between this and this. Normal distance is 400, right? So we want to create this panel here. We have a height of 210, 20 millimeter, then 70 millimeter, and that. So we go to file, new part, okay. We choose, I did change some settings here which are kind of giving me all sorts of issues. Right plane, sketch, you see it's like I'm clicking twice. Center rectangle from the origin, smart dimension, it is at 400, but we'll do 298 or 298.5 to give some clearance when you are inserting your partition. Yeah, it might not be difficult to fit it in there, right? So, fully defined. Base flange, material thickness same 1.5 millimeter. Click OK. Then create an edge flange here, going to this direction, and condition blind 20 millimeter. Click OK. Then we have an edge flange here, at 70 mil. Click OK. Another edge flange going to this direction, and condition blind, dimension 20 millimeter. That's okay. Then finally an edge flange going downwards, which is 15 or 10 millimeter if you want. This is to avoid sharp edge, right? Now go ahead and save this as part number 2. Part number 2, PW1A, you call it partition 1. Now we will go ahead and create partition 2, new part, click OK. And partition number 2 is the height of this. The total height of this is what? I did not show it. I think it should be about 210. 210. I think it's 210. 210. No, let us evaluate. Let us not do something that we are not sure of. So I will evaluate. Measure from this to this. What is the normal distance there? Normal distance is 180. Let's say 189. 189 plus 25. 189 plus 25. That should be 214. 215. So we continue. Go to right plane again, sketch, center rectangle, smart dimension 215 by 398. 398. Click OK. sheet metal, base flange, same material, same parameters, click OK. Edge flange, end condition blind, size 20 millimeter, click OK. Then edge flange going downwards, end condition blind 15 millimeter, click OK. Yeah, that partition is done. Go ahead and save it as part number 3, PW1A partition 2. Now we create this. Let us go ahead and create this. The height of the upright part is 280. The slanting part is 45 mil at an angle of 130, and the upper one is 20 millimeter. So we open file, new part, OK. Right plane again, new sketch, center rectangle, 398. This one 280. Click OK. Sheet metal, base flange, same parameters and everything. Edge flange, this end condition blind 45 degree, here is 130 or 130, 50 will give us, yeah, 50. Alternate angles and all that, right? That's good. Then finally we have an edge flange here which is parallel to this face, and condition blind, this is 20 millimeter. Yes, see the profile, how it looks. Go ahead and save this as part number 4 and call it PW1A. What are we going to call this? Outlet guard. Outlet guard. Now there is 2 angle lines for supporting the strainer basket, angle section and angle section. This angle section will be welded on top onto this outlet plate at the same height as this, so that this strainer basket sits on this angle line and on this partition number 2, right? So let us create that angle line, angle section, file, new part, OK, right plane, sketch, center rectangle from the origin. This is 398 by 20 millimeter. 2025 is okay. Yes. Sheet metal, base flange, parameter same, that's okay. Then edge flange here, and condition blind 20 millimeter, that's okay. Go ahead and save this as part number 5 W1A ankle section. What we are going to do is create the strainer basket. The strainer basket has a depth of what? Has a depth of 185. This should be 150. Yes, 185 by 150. But remember, it has an edge flange of about 20 millimeter round. So we are going to, let me open this isometric. We are going to deduct about 20 millimeter and 20 millimeter on this side. From the 398 we will deduct 20 millimeter. Let us do a new, we'll see how the base flange will look like. Top, sketch, center rectangle. This side is 150 and this is 398 minus 398 minus 20, that is 40. Let us do 50. Yes, yeah, that is our strainer basket. Sheet metal, base flange, same dimensions and all that. Yeah, before we do the edge flanges, let us create the perforations, because this is supposed to be a perforated sheet. So new sketch on that face. So we create a circle, click OK, smart dimension. The circle is perforations of 5 millimeter diameter. From the edge we give it around 10 millimeter, and also from this edge 10 millimeter. Click OK. Now can we do linear sketch, linear pattern direction, that one. 10 entity to pattern, that one in the opposite direction. 10, 11, 12, 13, 14. Yeah, I feel like 14 is good. Yes. Yeah, I feel like that is good. Click OK. Feature extrude cut. Why is it not fully done? Why is the sketch saying that it is not fully dimensioned? Sketch. I feel like my sketch is fully dimensioned. I don't know why it is saying use a sketch which is fully dimensioned. Link to thickness. Normal. No. Normal to this. We want to linear pattern the extruded cut. That is the edge. Feature to pattern is extrude and cut. How many do we require? Like 30? Let's see. 30 is not sufficient. We had, yeah, that should be about that. Well, this is not something that should worry you, because ideally you're supposed to be using a perforated sheet, which you will get it from the manufacturer with the perforations, right? So we create edge flange all around, and the height of this trap we have seen to be what, 185, and condition blind 185 is the height. Right click, that's about that. Let us do perforations on this face. Create new sketch, circle, smart dimension 5 mil, from the edge to the center 10, from the edge, the top edge to the center also 10 mil, and you extrude and cut. Go to feature, extrude and cut, and condition through hole. We want to do the pattern on both sides. Now we go ahead and do linear pattern on that axis. Yeah, that direction is good. The second direction here, same spacing and everything. This we can do 14 is not enough. We had a little bit. I feel like 17 is enough. This is just for illustrations. I have said it shouldn't worry you, because perforated sheet, they come from the manufacturer with the perforations. It will take some time. Yep, that's good. So select this face, a new sketch, circle, smart dimension, same parameters, 5 millimeter. Is the dia of the perforation from the center to the top, 10 millimeter, and from the center of the circle to the edge also 10 mil. Then you do feature, extrude and cut, direction through hole. Click OK. Your hole has been made. Then you go to linear pattern, choose that direction, change direction, change this to 14. Actually it's 14. Then direction 2, take it on the lower side, and that should be okay. Right click, give it time. Now we create edge flange on the grease trap, on the strainer basket. Edge flange, that edge, this edge, this edge. The purpose of this edge flange is for it to sit on the angle lines that we have created. They should be about 20, can even do 15 or 18. 15 would be ideal. There is no harm in doing 15 millimeter. 20, 20, Yeah, there is no arm. That's good. It is taking time because of these perforations. The perforations are not few. So we go to closed corner. We select this. As usual, we don't want this. That will be done. That will be a welding clear selection. This face matches with this face. Right click. That's okay. It will come. It should come. Now we can choose right plane and go to feature, mirror. We are mirroring about the right plane, and what we should mirror is closed corner 1. I told you, you can, whichever works for you. If you prefer doing mirroring or doing all the corners, then we go to front plane and mirror, entity to mirror. It is that mirror. Yeah, and your corners are there. Strainer basket is also advisable to have a double fold, right? A 10 mil double fold. Is it necessary? Not necessary. It's not necessary. It is not necessary. So go ahead and save this as a strainer. Part number 6. PW1S strainer basket. We'll need 2 of them, but they are of the same size. Now. We shall create handle for this. Then do sub-assembly of the same and the handle, okay? Now, what else are we supposed to create? We almost have everything. We need to create the lead. Let us evaluate and get the size of the lead. From this edge, that face to that face is 546. I'm sure also this is 446. From this to this, 446, yeah. So we go to new part, top plane, center rectangle. From the origin, 446 by 546, sheet metal, base flange, same material, same everything. Then we have edge flange, and the edge flange is on 3 sides only. Yeah, remember it will be sliding, and the height of the edge flange can do 15 mil. It should be sliding on top of this part, which is the rear part. It shouldn't have an edge flange. Yeah, when we are doing the assembly, I will mention that, okay? Save this as lead, part number 9, PW1A lead. Alright, now we create new part. Just a small leg of top, 25 by 25, center rectangle. This and this are equal, smart dimension 25 millimeter. Use a leg of 25 by 25. That would be okay. Extrude and condition 25 mil. You can choose direction 1 or midpoint, whichever works for you. Shell it so that it might be a square tube, complete a hollow section. Thickness 1.5. Yeah, so you have your leg there. Very small leg. Part number 10. PW1A leg. You need 4 of them. And also this, remember you have to do some grommets. You insert grommets under there. What other part are we supposed to design again? Yes, the handle of the lead. New part. No. We can create the lead, the handle. It will be good for your practice. Good for your practice if we do what? If we create the lead, the handle on the lead itself. So select that face, new sketch, and create a circle. From this edge, circle, smart dimension. This should be of a rod dia 8 millimeter. From this edge, from the center to the edge, you can give it something, say 50 millimeter from the edge, and from the origin, yes, this should be 100, say 100, so this is 50. That's okay. Now let me check, because I want to create a plane. Let me check what is the distance. 150. So let me click this OK, and I delete this so that I may make this dimension. It's driven. I will delete that dimension and do 150. From this to the center, we are doing smart dimension. What is wrong with you? The origin, let us do it at 150. I did 150 so that I may create a reference plane. Exit the sketch. I do a reference front plane. I do reference, then I offset it by 150 so that it may be at the center of that circle, because I need to create a sketch for sweeping. So select the plane and create a sketch. The sketch we shall create vertical line like that, then like that. That's okay. Take this and make them equal. Okay, then I choose this and the center of the circle and make them coincidence. Good. Then I smart dimension this to 100, and the height of this 35 millimeter. Then I do fillet of 8, because the rod is there 8. Do that and that. That's good. This and this. That's okay. Then I exit the sketch. I hide this plane. Then go to feature, sweep, profile is sketch number is that, and path. There you have your handle, right? And your lead as an handle. Save. I feel like also on the strainer basket we should create the handle, right? So we choose this face, right? Sketch, new sketch, circle, diameter also 8 millimeter. And from center to this, we can do the other one. We have done 100. Is 100 enough? I think 100 is enough, so this will do it 50. Looks a little bit big, but yeah, that is okay. Now this was, what was this, 15? So this we can do 7.5. Yeah, that's okay. Now let me check the dimension from the origin. That is 183. Exit the sketch. Then we create reference plane again. Front plane, reference plane, and offset it at 101.83, so that it goes to the center of the hole, right? New sketch on that new plane. Then we create another profile similar to what we have just done. Select this line, and this should be equal, and yeah, I feel like this and this point, I think they are coincident, right? Smarter dimension 100, height 35. The other one we did 35 or 30. Fillet radius 8 millimeter. So we fillet this, then this, exit the sketch. Hide the plane, sweep, profile is the circular profile, and path, sure, we have our handle. The strainer basket has taken shape. We go to front plane and mirror components. Is it components or mirror what? And what we need to do is mirror the sweep part. because you need two handles. Sure. So there we have it. I think we all have, no, we have one part which we have not created, which is the outlet and the inlet. New part. Create the last part, and this will need to create on the front plane. Front plane, new sketch, circle the origin. What's going on? Diameter 51. Extrude. Now let us do another circle. Or we have set. Sometimes it's good to use a different approach from the previous one. Instead of doing a shell, we just extrude it in the reverse direction. We extrude this as a hollow section. Extrude mid plane and make it around 75. This is just a pipe, so the size of this don't matter. Yes, save it as part number 11. We jumped part number 7 and 8. Don't know what was there before. We call this what? PW1A outlet, inlet. Outlet and inlet are the same size, so we only need one. So we go ahead and open our new file and start our assembly. The first part, we can insert this body. Let us jump the outlet because the outlet needs to be rotated, and I told you I hate rotating things. I just love rotating them while I'm inserting. Leg, partition, panel, angle section, strainer basket, then the lead. Yeah, we are good. So we do our mat. The first mat we are going to do is the leg, this face, flashes to this face, this face to this face, and this to the bottom. Yes, our leg is in place. We do the angle section, this face to this face, then this to this. Don't worry, they will take shape, and we can take the body, expand the body, and take the right plane of the body. Then we expand partition 1. That plane, yes. That's okay. Then this to this, yes. Then the angle section, the not right plane, but you need to be careful so that you may not do your own things here. that front and the front of the angle section. Where is the angle section? The angle section we expand. Yes, yes, that's good. Then we take this seat of the strainer basket sits. I hope you're following. Sits on that face. Right click. Then the front plane of one of the two and a front plane of, let us collapse this. We also collapse this. Can collapse this also. Basket, strainer basket. Yes, that's good. Then we can go advancement. No, let us take distance. This, the strainer basket is around 150 plus a few things there. 150. Yeah, we can do 150. We'll see. See, the beauty of this is that you can always do what? You can always do your editing from this face to this face. Yes, 150. Then the strainer basket, we go to advancement and do width between this face and where is my strainer? I want and this face. I'm not sure whether I'm choosing the right parts. Then this face. And this face. Is it good? Let me first exit that. Then this I change. No, he said we exit comes. Let me see whether transparency. Yeah, the strainer basket is sitting where it is supposed to be sitting. Everything looks in order. Looks like it is in order. Right. So we do this. We met this face. No. We do our met. This face should be welded right on this face, and the bottom of it to be welded on the bottom of the body. Yeah, then the right plane, the front plane of one of the front planes most of those front planes we have meted them. The outlet guard, front plane of the outlet guard. Yes, that's good. Now, that being done, I categorically have not so yes, also this is to be welded to the bottom of the strainer, not strainer but of the grease trap, and front plane to the front plane of partition number 2. Let us collapse this partition number 2. Yes. Then we do a distance of 150 again. 150, and that 150 is between this and this. Yes, so that we may have room for another strainer. Now let me insert component that I want to insert here should be the inlet or the outlet, not that one, not this clear selection. What have I done? Outlet. Yeah, I told you I like rotating them from here. So met this, the welding should be done from the inside, from that to that face. Then we make this concentric. This and this should be concentric. What's going on? Where is my inlet? Met. Concentric relationship. Not that one. That. And this. Why am I not seeing it? Choose this body end. First change that. Then we met. Concentric. This. To this. Yes, that's okay. And I'm going to change this. Now we met again. This face meets with this face. Not that face. Clear, delete that. Should meet with this face. Yes. Now we do the lid. this part of the lead sits on top of this. Then which plane is that? The top plane? No. We want the body. Expand the body and go for the right plane and right plane of the lead. Right plane of the lead. Sure. Now, I might not add the other, and this partition is all. Something is not right. We are going to change something there. Okay. This is not right. This should flash with this. Which one flashes with which one? And flash with this. No, that is not right. We'll take a look, because this is not right. Why did I do it at 280? It shouldn't. It was supposed to be at 230. This part here. This part, I did the sketch not to it 230. 230. How did I make it? Because it is not supposed to be touching the bottom of the yes, it's supposed to be like that. Now the lead, I might not want to add another relationship, because see, I was saying it is supposed to be sliding like that and going all the way to this edge flange here acts as the stopper. Okay, as the stopper, because you see this grease trap is going under there, under the sink, right? And assuming that your sink is on top here, the bowels, the bottom of the bowels are somewhere here, plus the bottle trap connection, so you will hardly have space to be lifting the lead, to be moving the lead on the upright direction. So you can only have it sliding, right? Sliding on top of the grease trap. But it is not a must that you place your grease trap under the sink. You can place it elsewhere, as long as the drainage from the sink comes to the inlet of the grease trap, then the outlet goes to the drainage system, you are good. But for the purposes of utilizing space, stack this thing under the sinks. Okay, so insert component, and component that we want to insert here is outlet. Where is this outlet, and we rotate it, which is our inlet now. Met concentric relationship between that and the, that's okay. Then this face to this face, that's okay. Your welding should be in here. I will insert again an angle line. Insert the angle section, and rotate it accordingly. Rotate, because it goes on this other side. But the angle line should flush, the top of it should flush with the top of this partition number 2, and this face, sorry, the face of the angle line should be on the face of the outlet guard, and then not that front plane, but the front plane of the body, or any other front plane of the body and front plane of the angle section. What's going on here? Yes. Yes, see? That's good. They are flashing. We meted this face and this because the strainer basket will be sitting on top of that and should be parallel to this surface or the bottom. So we insert again strainer basket, because we are requiring 2. The strainer basket we met, and this bottom part sits on top of the angle line, the angle section, or this face here. That's about that. Then we go to we can take, because they are of the same size, this face and this. That's good. Then we go for width, advanced mate width, that is between this face and this face. Then choose this face and the opposite face. Where is that opposite face? This. I hope I didn't complicate issues, man. Nope, no. That's not right. Yeah, that's about that. That is good, very good. Let me see. No. Yeah. There is something I should edit here. I should edit. This is sitting well. 150. Let us go to this mate. Width. No, distance. This distance here. We edit that distance. It is between which face and which face? 150 between that. It shouldn't be between this face and that. So we delete this and make it 150 between this, the angle line. Yes. 1 second, please. Yes. See, now the strainer basket is not touching this partition, and the edge flange is the edge flange. That edge flange, should it be 150? go back and edit it, this distance, edit. We gotta get it right. It shouldn't be 150, but there it is sitting well. 150 looks nice to me. Yeah, let me see. Something width. Yes, we had it. Then this face and this. We clear this. We shouldn't have cleared that. It's okay. We choose this face and the face of the angle line and this face. Yes. No. Perfect. Our thing is good. Very good. Now, as you can see, the strainer basket is sitting very well on this angle line, and it is sitting well on this plate, and there is a gap. Sure, there is a gap between. No. So let us edit that to 150 and make it 180. This distance here, we had it from 150 to 175. 175 is big. Yeah, it is big because the space that is occupying is too small. Even here it is almost sitting on the edge, so 155. Yeah, there is that clearance. We're looking for this clearance. You don't want to make something and insert in the strainer, it won't fit. Yes, the other basket is sitting well. Even this basket, we need to edit something here. We edit the first width is good, distance we had this to 155. Do we have that clearance for the strainer basket? Yes, it's there. See, there is good clearance. There is good clearance there. Good. So sometimes it is better you take a lot of time doing your designing, and once you're done, you will be happy about your work, because when you're doing the fabrication, the assembly in the fabrication itself, you won't have a lot of issues. Now that you have seen how the lid is working, let me go ahead and finish the mate of the lid, so that the lid may fall in its position, in its right position, which is this face. Clear this, and we are looking for this face. Touches this face. No. We change this mat, and what we are mating is this face to this. Yes, there you have your grease trap. Now one thing is remaining here, and what is remaining is to do a couple of mirror entities, mirror components. Component to mirror here is this leg. Then you go for front plane and the mirror components to mirror is that final mirror is this and this. See, and your grease trap is ready. Lock and load, baby. The grease trap is ready. Say PW1 1A grease trap. Right, so if I could change this to transparency, is it transparency? Now you can see your grease trap. Yeah, like I was saying, this partition you will do welding here. You don't want anything flowing through here, so the fluid comes from shower to the basket, out to this gap here, then to the other basket, then down. Is there a gap between that and that? There should be a gap, then to the outlet, right? Yes, so thanks so much for your time, fellas. See you in our next video.